So in this video, what I plan to do is to demonstrate how to conduct a one-way ANOVA by hand to illustrate the processes and where the numbers come when you click in an SPSS to run all of this. Remember, the ultimate goal of the one-way ANOVA is to compare the means of at least 3 conditions in a particular experiment. And what I'm going to do is I'm going to go through these steps. I've broken this down into 5 steps to show you how this process works. And to start, just to give us some basic data to work with, let's say that we have, and hopefully the focus will stay in, let's say that we have one group, and let's say we have 3 scores within each one group, just to be general about it. 1, 2, and 5. Our second group has 3 scores, 2, 4, and 2. And then finally, our third group has 3 scores, 2, 3, and 4. So starting off, here's our initial basic data set for our 3 groups. So where should we start? Well, let's start down over in here with step number 1. The best place to start is to go on and state the hypotheses of the one-way ANOVA and to specify the alpha level that you plan to use in your study. Again, all of this is done a priori. So if we set our hypotheses, so the null and the alternative, we're going to keep things very basic when we state these hypotheses. So again, the null hypothesis is that nothing's happening, nothing's going on, and there's no difference between the means of our 3 conditions. So the way that we write that is H0 colon mu1 is equal to mu2 is equal to mu3, indicative of no difference amongst the means. Now alternatively, since we have 3 means, there can be a lot of different outcomes of this, alternative outcomes. And so at this point, the way that we're going to do this is we're not going to make any specific hypotheses. We're going to alternatively hypothesize that there is at least one difference among the means. So again, being very straightforward and simple, nothing's going on here in the null hypothesis. Alternatively, something's going on. Now for our alpha level, generally the accepted one that we're going to use in our class, alpha of 0.05. Okay? And that's step 1. Now, step 2. Step 2 is a step where we're going to analyze the degrees of freedom to determine the critical value with which we will compare our test statistic to. And for our one-way ANOVA, we're going to be using the F distribution as we talked about in class. And so first we need to determine the degrees of freedom between groups and within groups in order to determine the critical F value. And so to start, what we need to do is to find the degrees of freedom between groups. What we're going to do is take K, where K equals the number of conditions that we have in our study, and we're going to subtract 1 from that. So in our case, K equals 3. 1, 2, 3. So we take 3 minus 1, and the degrees of freedom between is equal to 2. The degrees of freedom within is equal to n, where n equals the total number of scores that we have in our sample, and you're going to subtract the number of conditions that you have, k. So if we look at our data, we have 3, 6, 9 total values, and we have 3 conditions. So our degrees of freedom within is equal to 6, giving us a total degrees of freedom, if we add up over here, 6 plus 2 of 8. So after those calculations, we have the 2 key values that we need in order to find our F critical value. So if we write this out, F critical is equal to, and the way that we find this is to use the F distribution, and I'm going to put the table up here. Okay, hopefully we can see this. On this table, along the top, you have the degrees of freedom for the numerator, and that, if you remember from class, is going to be the degrees of freedom between. And then down the side, we have the degrees of freedom for the denominator, and for us from class, that's the degrees of freedom within. So we know that our degrees of freedom between, which we calculated, was 2, and we also know that the degrees of freedom within was 6. So if we come down the 2 column to 6, we're going to use this number here, which is 5.14. So if we bring our calculations back up, our F critical value is going to be 5.14. And that completes step 2. Step 3, since this is the analysis of variance, step 3 is going to be the most detailed portion of this process. And here's where we're going to do the analysis of the sum of the squares, or the sum of squared deviations from the mean. For each, we're going to do it for the total, which is everything combined, total variability, and we're going to do it for within and between. Okay. So the first place that we're going to start is to calculate the total sum of squares. But the first thing that we need to do is actually calculate a mean for each condition. So for each condition, we're going to calculate the mean. So for group 1, the mean is equal to 1 plus 2 plus 5 divided by 3, and that's going to give you a value of 2.67. Then we're going to calculate the mean for 2. 2 plus 4 plus 2 divided by 3. That's going to give you 2.67. And then you're going to do the same for the third. 2 plus 3 plus 4 divided by 3 is going to give you an even 3. So you've calculated the means for each sample. The next step is to calculate a grand mean. So the grand mean is going to be the grand sum of everything that you have, okay, in the study. So that is all of the scores totaled. You're going to divide by how many total scores you have. So our grand total, where we add up all of this, 1 plus 2 plus 5 plus 2 plus 4 plus 2 plus 2 plus 3 plus 4. So what is that? That is 1, 3, 8, 10, 14, 16, 18, 21, 25. So that's 25 divided by n, so that's 3, 6, 9, is going to give you a grand mean of 2.78. And so then what we're going to do is actually get into actually calculating the total sum of squares first. So this is all, everything together, all variability across the conditions. So if we start off, the sum of squares total, and let's just look at the formula. It's going to be the sum of each score minus the grand mean squared. Okay? So this is the sum of the squared deviations from the grand mean. And so how this will work is we're going to take 1 minus the grand mean of 2.78, square it, and then add 2 minus 2.78, square it, plus 5 minus grand mean 2.78, square it. And we're going to do this for all of the conditions. So if I keep going, we'll have 2 minus 2.78 squared plus 4 minus 2.78 squared plus 2 minus 2.78 squared. And then we're now on our last condition for 2, 3, and 4. 2 minus 2.78 squared plus 3 minus 2.78 squared plus 4 minus 2.78 squared. And if we add all this into a calculator, our sum of squares total, so SS total, is going to equal 13.6, let's say. So the total sum of squared deviations from the grand mean is 13.6. Now the next step is to calculate the sum of squares within. And so the formula for the sum of squares within, you're going to do within each condition the sum of x1 minus the mean of that condition and square it. So you're going to do within each condition the sum of the squared deviations from the mean of the condition. Then you're going to add these together. So x, each score in condition 2 minus the mean of condition 2 and square it. And do the same thing for the third condition. 3 minus the mean of root 3 and square it. So what this will look like, we're going to take 1, so start off here. 1 is our first number in condition 1, subtract the mean for condition 1, which is 2.67, and square it. And then you're going to add 2 minus the mean, 2.67 squared, and then 5 minus 2.67 squared. And then you do the same thing for condition 2. So 2 minus 2.267, which is the mean for condition 2, 67 squared, plus 4 minus 2.67 squared, plus 2 minus 2.67 squared. And then we do the same for the third condition. And remember, our mean was 3. So we are going to do 2 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared, such that our sum of squared within, once we calculate all of this, will be 13.34. Now we need to find the sum of squares between, and to do that it's very easy. We take the sum of squares total, which is 13.6, minus the sum of squares within, which is 13.3, and when we do that we get a sum of squared between value of 0.23. Sum squared between 0.23. And so with that, we now have completed step 3 of this process. And so now we only have 2 steps left, and we'll put it over here. Okay, so step 4. Now we need to actually calculate the variance between and the variance within. And so essentially you're going to calculate first the mean squared between, which is essentially the variance between. And to do that, you're going to take the sum of squares between, and you're going to divide that by the degrees of freedom between. And if we do that, we have these values. So our sum of squares between was 0.23, and our degrees of freedom between, if we look up to the top, was 2. So we divide by 2, and so our MS between is equal to 0.12. Now we need to do the same thing to calculate the variance within, which is the mean square within, again is the variance within, and it's going to be the sum of squares within divided by the degrees of freedom within. And so from our work earlier, we know that sum of squares within is 13.34, and divided by the degrees of freedom within, which we know from earlier is 6. So 13.34 divided by 6 gives you 2.22. And so now we're finally on our last step here. And so if I give us some more paper here. So our final step, step 5. Here we're going to actually calculate our F value, our F statistic for this particular data set. So to do that, F is equal to the mean squared between, or the variance between, divided by the mean square within, or the variance within. So you're dividing the between groups variance and the within, the between and the within groups variance. And those values, as we just calculated, were 0.12 and 2.22. So mean square between 1, 2 divided by 2.22. And so we come out to a value for F of 0.05. Now, if we bring back our F critical value, which is the F value to which we compare our actual f, it was 5.14. So we find that our f of 0.05 is less than 5.14. Okay. So based on our data, we did not actually get into the critical region for rejection of the null hypothesis. So in this case, we fail to reject our null hypothesis. Okay. And remember, our null hypothesis was that mean 1, or mu1, was equal to mu2, was equal to mu3. And so that null hypothesis here states that there is no significant difference between the three groups. And so since we failed to reject that, that is what we conclude. There is no significant difference between the three groups.